So first one I want to go over is a median. Okay, the median of a triangle is a segment whose endpoints are at the vertex of the triangle and the midpoint of the opposite side. Okay, so we are connecting an angle to the opposite side midpoint. So that's what we're going to do for the second part right here. We're going to draw in these medians. Now remember when we drew in perpendicular bisectors that also hit at a midpoint? So we are going to take the straight edge part of our protractor, okay, and we're just going to count and then divide it by 2 to find the midpoint, just like we did before. So that segment across from angle A, okay, you place your protractor down. We can count out how long it is. You got about 13. Okay, it's fine. Just divide it in half. Okay, so if I got 13, that's about 6.5. So I'd go to 6.5. Okay, so that point I just created is the midpoint of that side. Okay, when you have a midpoint of your side, that means your two segments there are congruent to each other. Now with a median, all we have to do is connect that midpoint to that opposite angle A. So we can just take our straight edge, connect the point we made to that angle. Okay, that is your median. Okay, we'll do the same thing for this triangle over here. So we need to count out the side length across from angle A. So that is the hypotenuse of this triangle right here. Okay, so this length. So count those dashes. I got about 24. Divide by 2. That's 12. Make that point at 12, right? Yeah. What, my protractor? Okay, so from that midpoint, okay, we can connect that point to angle A.
So why don't you do the bottom one?
We want the opposite side from angle A because we're trying to make the median from A. So whatever one you're trying to make that median from, or angle you're trying to make that median from, you want the opposite side, midpoint. Okay, so last one, same thing. Point A is this one right here. So that means we need to count out this side over here along the left. Okay, once you count it out, divide that number by 2. And then connect that midpoint to your angle. What? Okay, so that's all a median is. Okay, it's your midpoint to the angle. So just like with perpendicular bisectors and angle bisectors, medians also have a point of concurrency. Again, that's the point where all of them meet in a triangle. Okay, so all three meet. So the point of concurrency of the three medians of a triangle is called the centroid. Okay, it's the centroid of that triangle. So we are going to draw in the three medians in our triangle. Okay, so use your protractor. Count out your side. Connect it to the opposite angle. And make sure you do it for each side of that triangle. So you should do it 3 times. Okay, and again, they shall roughly meet at the same point. Make sure everybody has all 3 here. All right, so you should have these 3 segments drawn in. So this point right here where they all meet, that is your centroid. Okay, so that's where all 3 of those medians meet. Now, since your median hits at a midpoint, that means each of your segments are congruent. So this bottom one, I have 2 congruent segments. The one on the left here has 2 congruent segments, and the one on the right. Okay, so it splits that segment into 2 equal parts. So we have a centroid theorem that goes along with this. That states the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So the piece that is 2/3 of your segment is from your centroid to your angle. Okay, so this length right here is 2/3 the entire length of your segment. Meaning from your centroid to the side is 1/3 of that. Because when I add 2/3 plus 1/3, I get 3/3, which is just your entire segment. Okay, so 2/3 of the segment is that top portion between your angle and your centroid, and 1/3 of that segment is from the centroid to the side. So let's say I label this. This segment is AM, and I'm going to label my centroid as O. Okay, let's say AM is equal to 33. Okay, that entire segment is 33. And I want to find the length from O to M. Well, I know since the entire segment is 33 and OM is 1/3 of that, what would OM have to be? 11. Okay, when you see this fraction, that means you're just dividing it by 3. So 33 divided by 3 to get that segment from the centroid to the side. So now if OM is 11, what's AO? 22. Okay, so if you're given that segment that is 1/3 that distance, so 11, to get the 2/3 part, you just multiply it by 2. Okay, so take that 1/3 portion, multiply it by 2 to get the 2/3 portion. Okay, so we are going to practice that below here. Okay, so we have our triangle CDE with U as the centroid right here. That means each of these are medians. Okay, so if U is the centroid, that means each of these segments drawn in is a median. Now we're also given that UK is 12, EM is 21, and UD is 9. Okay, so what I like to do is just fill in each thing before I even go over here. So with UK being 12, that's going from your centroid to your side. That's your 1/3 portion. I want to find this 2/3 portion. Okay, to find from your angle to the centroid, all I have to do is multiply 12 by 2. Okay, so CU would be 24. Okay, so if you're given from the centroid to the side, multiply by 2 to get from the angle to the centroid. Now here, if I have UD is 9, that's not to the side. So that's the 2/3 portion of that segment. Okay, what should I do to get the 1/3 portion then? Not by 3. By 2. Okay, I already have the 2/3 portion. I need the 1/3 portion. So it is 4.5. Okay, think about it as splitting your segment into 3 equal parts. So if J to U is one of those equal parts, then U to D I need to split in half to get those 3 equal parts there. Yeah.
So here we divided 43 by 3, right?
To get the 1/3 portion, yep.
So why did it want to different?
Because 33 was the entire segment.
Yeah.
9 is only part of the segment.
So we divided by 2?
Yes. So if you had the entire segment, you can divide it by 3 because it's split into 3 equal parts. This from U to D is split into 2 equal parts. So each of those parts has to be 4.5. If you're splitting that entire segment into 3 equal parts. Okay, so next I have EM is 21. So that's the entire segment. So then I know to get the smaller segment here from U to M, that's when you divide by 3 because you already have the entire segment length. So I want to divide 21 by 3 to get UM. That's 7. I have the entire segment. Your entire segment is split into thirds. From U to M is 1/3 of your segment. So I can take 21 times 1/3, which is the same thing as 21 divided by 3 to get 7. Okay, then to get your 2/3 portion here, you can take your 1/3 and multiply it by 2 to get the 2/3 to get 14. Okay, so each of these segments divides into 3 equal parts. So from here, since I've labeled each of those inner segments, now I'm going to go back and answer all my questions. So number 6, we wanted to find CU. Okay, that's 24. Number 7, we want to find MU. That's 7. 8, we wanted to find CK. So that's the entire segment. That means I have to add 24 and 12 together. That's 36. Number 9, I need to find JU. Okay, we divided by 2 to get 4.5 there. And then 10, we want to find EU. Okay, EU is 14. And then JD, I have to add those two segments together to get 13.5. Okay, so if it helps, split your segment from your centroid to your angle in two. So you know it's that 2/3 portion. Okay, so if I split this in two, I then now know this is 7 and this is 7. So this also has to be 7 because you're splitting it into 3 equal parts. Okay, so 7, 7, and 7. Okay, 4.5, 4.5, 4.5. They each have to be equal parts. Okay, questions on that before I move on to altitudes? All right, then on the back, our next segment in our triangle is called an altitude. So the altitude of a triangle is the perpendicular, again, perpendicular segment from a vertex, so your angle, to the opposite side or to the line that contains the opposite side. Okay, so you're going from your angle again, okay, to the opposite side, but it has to make a 90-degree angle with that opposite side. Okay, so we're not going to use a protractor for this one. You're never going to have to actually draw this in. So from your angle, you just need a segment drawn to your opposite side that is perpendicular. Okay, so it makes that 90-degree angle with the opposite side. So if I go from A here to make this perpendicular, I would just go straight down to that right angle. Okay, so your altitude is just on that angle. So this is an acute triangle. This is a right triangle. I'm going to do one on the side here from an obtuse triangle. Okay, so with your obtuse triangle, it is a little bit different. So if this is my angle A, I can't really make a segment that hits this opposite side here that would make it 90 degrees. So what we do is extend that bottom line, and your altitude then gets dropped down on the outside. So the altitude of an obtuse triangle is on the outside of that triangle. Okay, so this line right here would be your altitude. And again, you won't have to draw those in. I just wanted you to know that it can be on the outside of a triangle. So just like with our other 3 segments, okay, we have a point of concurrency for altitudes. Okay, that point of concurrency is called the orthocenter. Okay, orthocenter of the triangle. So we have our 4 different segments within triangles that we can make. All of them have a point of concurrency. For your altitudes, I just said what it was. It's an orthocenter. Okay, so your point of concurrency for 3 altitudes is the orthocenter. Point of concurrency for 3 medians is a centroid. For your 3 perpendicular bisectors, the circumcenter. and 3 angle bisectors.
Who makes up these?
That is the incenter. Okay, so you have your your 4 different points of concurrency. Okay, so each of those 4 segments has a point of concurrency with a specific name. So what I want you to do next here, I'm going to draw in your special segments, and you're going to label them after I draw them in. Okay, so here's one. Don't shout it out. Just label it for now. Okay, so your 4 different segments are altitude, median, perpendicular bisector, or angle bisector. Okay, so label each of those with one of those 4. Okay, it's either perpendicular bisector, angle bisector, a median, or an altitude. 2 of them are on your note sheet from today already that we drew in. So label each of those. All right, what's the first one? It is a median. Yes. Okay, the next one is an altitude. Third one. That one is a perpendicular bisector. Okay? For perpendicular bisectors, it has to be perpendicular and it has to be at the midpoint. Last one. It is an angle bisector. Okay, last part here, we want to compare and contrast perpendicular bisectors, medians, and altitudes. Okay, so I'm going to compare perpendicular bisectors and medians first. So if I look at perpendicular bisector and median, what is the same about those two? They're at the midpoint. Okay, so that's comparing them. What's different about them? This one, it has to be perpendicular. So that's what I would want to write about those two compared. Okay? So the perpendicular I did spell it right. Perpendicular bisectors and medians meet at a midpoint. Okay, so that's what was the same about them. Okay, but But perpendicular bisectors must be perpendicular to the side. Okay, next I want to compare. So I just did perpendicular, bisector, and median, right? Yep. Next I want to do perpendicular, bisector, and altitude. Okay, so these two, perpendicular, bisector, and altitude. What's the same about them? Yes, but what about this angle? They both have right angles, so they both have to meet at a right angle, or 90 degrees. What's different about them? Perpendicular bisector has to be at a midpoint. Okay? That's fine. That upside down T means perpendicular, by the way. Uh-huh.
I was gonna say something.
Parallel?
Last one. We have medians and altitudes. Okay, median and altitude here. What's the same about that? They both go to an angle. Okay, they both connect to an angle of your triangle. Okay, difference here, median has to be at the midpoint. Okay, so both have to connect to the angle, but only medians have to meet at the midpoint. Almost done. Okay, I had to compare and contrast all of those. So you have to do perpendicular bisector and median, median and altitude, and perpendicular bisector and altitude. Okay, to answer that question fully. Okay, you would have to do all of that.